So hi everyone, how are you guys doing? First of all, let me welcome you guys to the Unacademy JEE English, which, as you know, is the largest online platform in online learning for IIT JEE. And this is a new channel by Unacademy where every concept of physics, chemistry, and maths are being taught to you completely in English. So this is a series that I'm hosting for class 11 students. The topic that we are discussing right now is fluids. So this is lecture number 6 of fluids, and today we'll be talking about viscosity and surface tension. Now, before we move forward with today's lesson, let me just introduce myself for those of you who might not know me yet. So my name is Rohit Dixit and I studied mechanical engineering from IIT Delhi. And for almost past 8 years now, I've been teaching physics for the IIT JEE exams, both mains and advanced. And for 7 years, I was associated with some of the topmost offline institutes that you know of. And for past 1 year, I've been teaching online now. As a student, I myself was All India Rank 447 and All India Rank 192 in the two stages of the IIT exams that I took. I also qualified the NTC Stage 2 examination as a student, and I was in the top 1% in the SCP exam as well. In my offline career of teaching, I have coached many students to top ranks in the JEE examinations. Hello, Siddharth, how are you? And now I hope to continue doing that here online with you guys. Now, students who are worried about how to go about their preparation in this period where most of the students don't have access to any kind of teachers, forget about good teachers. So there's a great solution for you guys. You guys can get for yourself the Unacademy subscription. Now, this Unacademy subscription will give you benefits like live classes where you get to interact with your educators on a regular basis. And you also have live polls and leaderboards in these classrooms, which keep them highly interactive and quite efficient. Then you have test series and regular analysis sessions. Again, they keep you on your toes and well aware of your standing in the competition and let you know where to focus more and how to prepare better. And finally, you have live doubt clearing sessions. So for all Unacademy Plus courses, you realize that every fourth session is supposed to be a live doubt clearing session. Okay, so after every 3 teaching sessions, you have one session entirely dedicated to solving the doubts of students, be it doubts about theory, be it doubts about problem solving. Okay, so along with all these benefits and the best of all, now you're getting the opportunity to study from the best educators all across the country with the help of this subscription from the comfort and safety of your home. So along with all these features, I think this is a wonderful opportunity for all students looking to crack their JEE in the coming years. Now, how do you avail all these benefits and how do you benefit from these features? So the first step involves for you to install the Unacademy app. The moment you do that, you will realize you can attend a lot of free courses. Then you can attend special classes. And finally, you can take part in quizzes. So these are free features that are available on the Unacademy app. So to avail all these free features, all you need to do is just install the app and that is it. So to unlock these free features, all you need to do is install the app and apply the welcome code RD Live, and that's it. That's it. You are done. You can start studying and start your preparation for IIT. Now, when you decide finally that you want to take the plus option, then these are the steps that you need to follow. You can go to the plus section of the app, select your goal as IIT, and click on that Get Subscription button. Now, when you do that, you'll be redirected towards the payment page where you will find a box that will say, do you have a code? So that is where you can enter this code, RD Live. This code will give you a 10% off on all your subscription fees, be it for your plus subscription, be it for your iconic subscription. Fees of these subscriptions are as mentioned here, and you'll also realize when you click on proceed to pay, you can break these payments also into a lot of no-cost EMIs to reduce the burden of these payments. Now, those of you who do not know what the iconic subscription is, so hello Rishabh Pal, how are you? Have you covered KTG and thermodynamics in review? No. Yes, I have. In fact, in quick review, we just finished waves. Okay, so thermodynamics review has already been done. Okay, you can check out those lectures. Now, those students who don't know what the Unacademy iconic subscription is, so this subscription will take your IIT JEE preparation to the next level by allotting you personal coaches. So from our team of experts, you are allotted personal coaches. These personal coaches will personally mentor you and guide you throughout your IIT JEE journey, along with giving you these extra benefits. So you get to attend IIT JEE workshops, receive expert guidelines from time to time, get a study planner, and get a regular test analysis sessions. So these features will make sure that you power through your IIT JEE journey and reach your dream ranks and hence dream colleges. Next, those students who have just entered class 11th and are wondering, how to go about their next 2 years of preparation can go for the combo subscriptions offered by the Unacademy. Unacademy offers you 4 combo subscriptions which take care of all your study needs for the next 2 years, be it your class 11 CBSE, be it your class 12 CBSE, be it your board examinations, be it your IIT JEE Mains, be it your IIT JEE Advanced. So the first combo that you can opt for offers you the iconic subscription for IIT JEE and the plus subscription for 11th and 12th. This subscription starts at around 4,600 a month. The next subscription that you can choose is offers you the iconic subscription for all three. This subscription starts at 5,500 a month. Next, you can choose a subscription that offers you the plus subscription for IIT JEE and plus for CBSE 11th and 12th. The subscription starts at combo starts at around 3,000 a month. Finally, you have a combo which offers you the plus subscription for IIT JEE and the iconic for 11th and 12th. And this combo starts at 3,900 a month. Depending on where you think personally you need to focus more, and depending on your study needs, you can choose an optimum combo plan that suits your study needs and then leave all the study worries for the next 2 years behind. Next, those students who are following us on the JEE English channel of YouTube, do not forget to connect with us on the Telegram app using this link. Okay, so that will make sure that you are receiving timely notifications for every session and lecture happening here on this channel, and so that you're not missing out on any of this amazing content given here. All right, so with that, let's get started with our discussion for fluids, and let's start the lecture 6. All right, so first we were talking about viscosity in the last class. I told you the force of viscosity is essentially internal friction of a fluid. Okay, and viscous forces, what they do is viscous forces oppose the relative motion of one layer of the fluid with respect to another. And experimentally, Newton found this equation, and this is known as Newton's law of viscosity. Okay. So here, what Newton suggested was that the force, viscous force acting between two layers of fluids is directly proportional to the area of cross-section in contact for the two liquids and directly proportional to the dV by dy, which is the velocity gradient. So as you move down from one layer to another, if one layer is being moved, so the velocity of every subsequent layer reduces, establishing a velocity gradient, which is measured as dv over dv over dy. So it turns out the viscous force is directly proportional to this velocity gradient and directly proportional to the area. And I told you the logic of that also. Okay, it is this force is due to the intermolecular forces between two consecutive layers of a fluid. Okay, so this is the final equation that we have, and this is the equation that we are going to use to solve all the problems. Now here, neta is called the coefficient of viscosity. Now this coefficient of viscosity depends on the nature of the liquid, its temperature, and other properties. Okay, you would have seen if you pour hot oil somewhere, it flows to a greater distance, and if you pour cold oil, then it would flow to a smaller distance and stop. So you can realize hot oil has lesser viscosity, okay, compared to cold oil. So that is because the neta will depend on the temperature of the liquid. Okay, so here are the factors on which this coefficient of viscosity depends. So its value depends on the nature of the liquid. Okay, then the SI unit of the coefficient of viscosity are decapoise or Pascal second. Now, its value is usually determined experimentally with the help of Stoke's law. Okay, so these are the things that you need to know. Nature and temperature also. Okay, that also should be added here. Next, we talk about Stoke's law. This is the main part of the viscosity that on which most of the questions are asked. So Stokes' law and terminal velocity are very, very important. So let's go about that. So when any object is moving in a fluid, it experiences a viscous force which acts opposite to the direction of its velocity. So it is a resistive force, you know. So if anything is moving in a liquid, then it will also experience a viscous force. Why? Because suppose you have an object like this. So one layer which is in contact with this, so the layer which is touching this gets stuck on this. So any other layer with respect to which this is moving, that layer applies a viscous force on this. Okay, and that is how these any body moving in a liquid will feel a dissipative or retarding force, in fact, due to the viscous nature of the liquid. Okay, now the viscous force on a spherical object of radius r moving with a velocity v in a uniform viscous fluid is given by F equals 6 pi neta rv. This is what you call Stokes' law. So what you realize is that this force is directly proportional to the radius, because that will determine how much surface is in contact with the fluid, and also depends on the velocity. Okay, because you realize from this equation, the more the relative velocity between two layers, two consecutive layers, the more is the viscous force. So that V determines the relative velocity of the liquid which is stuck at the solid and the liquid which is just away and moving with respect to this. So the relative velocity will obviously depend on V, and that is why this viscous force also depends on V. Okay, hi Tanya, how are you? Okay, so if a spherical object of radius r and density rho is falling in a liquid of a density rho, then the terminal velocity of the object is given like this. So what you realize is what is happening is let's try and prove that equation. So what is happening is imagine when a solid is falling through a liquid. Okay, so imagine that you have a container, a very long cylindrical container, which is filled with some liquid, and when this solid is falling through, then the kind of forces it experiences are as follows. So it will experience some mg. Now it will experience a buoyant force and it will experience a viscous force. Correct? Now mg and buoyant force are fixed, but the viscous force depends on the speed. So what you realize is that at any instant the net force F external net, how much will that be? That will be mg minus b minus fp. So what you realize is mg is fixed. Mg can be written as 4 by 3 pi r cube, r being the radius, into rho of the solid. Okay, and sigma is the density of the fluid. Buoyant force similarly would be minus 4 by 3 pi r cube to sigma. So this is mg. Okay, so and this one color for this. This is what you can write your mg as. Now similarly, you can write your buoyant force as this. This is what your buoyant force is. So these two have fixed values, correct? Then of course you have your viscous force, and viscous force is minus 6 pi neta r v. So you realize initially when the velocity is zero, when the particle has just been dropped, then the net force would be downwards because we have assuming that rho is greater than sigma. It experiences a net downward force and hence it starts to accelerate. Now as it accelerates, you realize what happens is that from here I can say that the acceleration dv over dt is in fact, this is some constant. This entire thing is some constant. Okay, so I can rewrite this as 4 by 3 pi r cube times sigma minus rho minus sigma minus 6 pi r v. Okay, so your acceleration, of course, m dv by dt becomes this. Okay, so what you realize is that initially the acceleration uh, would be when v is zero, the acceleration would be this by m, and then as your speed increases, the acceleration or the net force keeps on reducing. Now there will eventually come a point where the net force will become zero, and that is where the object will achieve a terminal velocity. The graph of velocity versus time is going to be like this, and eventually the object will achieve something which we call as terminal velocity. It will start moving with a constant velocity. At terminal velocity, what I can say is at terminal velocity, the summation of external would be zero. Okay, so summation of external is zero, so I can say that therefore 6 pi neta r v would be equal to 4 by 3 pi r cube rho minus sigma. Okay, now from here, what you realize is you can cancel out these pi's, cancel out one r, and this becomes 3, this becomes 2. So what you get is that Vt is 2 by 9 rho minus sigma r square over neta, okay, which is the expression mentioned here. So that is the derivation of this expression. Now this expression is very, very important. Most of the questions are asked using this expression. Now you will also realize if if your sigma is less than rho, if the density of the object is less than the density of the fluid, then the terminal velocity achieved would be upwards. Otherwise, the terminal velocity achieved would be downwards. So practically, finding neta is very, very important because a lot of Equations of fluid flow are governed using Poiseuille's equation, which is been removed from your IIT JEE advanced syllabus. Okay, so we won't be talking about that. But Poiseuille's equation requires the expression, the value of neta, and the value of neta is now practically found using this law. Okay, so what you do is, suppose you have to find the value of coefficient of viscosity for petrol. So what we do is, practically we take a cylinder, fill it with petrol, drop an iron ball of known radius, and eventually measure its terminal velocity. When you measure its terminal velocity, you put everything in this expression and you can find out neta. Okay, because the density of the steel ball, the density of petrol, everything else is known. Okay, so the neta is calculated like this. So that is the main application of this Stokes theorem and terminal velocity. All right, so why don't we try one question from viscosity then? Let's take up a typical problem which is asked from viscosity. Okay, so here you have a question which says a plate of area 2 meter square is made to move horizontally with a speed of 2 meter per second by applying a horizontal tangential force over the free surface of the liquid. Now, if the depth of the liquid is 1 meter and the coefficient of viscosity is 0.01 poise, then find the tangential force needed to move the plate. Okay, so let's try this question. Now, please remember the units. Okay, here the coefficient of viscosity has been mentioned as poise. What were the SI units? SI units is decapoise. Okay, what is deca? I hope everybody knows what deca is. Okay, so keep that in mind while solving this question, and let's see if you have an answer for me. Okay. So hurry up and try and give me a quick answer. Okay, so anybody having an answer? क्या कर रहे हो यार? ट्राई भी नहीं कर रहे. अच्छा चलो देखते हैं. डेका पॉइस क्या होता है बाय द वे? So neta is 0.01 poise. Now 1 decapoise. Deca means 10. 1 decapoise equals 10 poise. Okay. So the SI unit of this is 0.001 SI. Okay. Now once you figured that out, rest of the thing is very, very easy. You realize what is happening is that you have this. Let's draw ourselves a diagram. You have this plate. Okay, for this, and you have a liquid here. Okay. Now you have to pull this with some force, and that force, in order to move this with a constant velocity, this force must be equal to the viscous force. Okay. To move the plate with a constant velocity, F must be equal to viscous force. Okay, because this plate will feel a viscous force in the opposite direction. Okay, the lower liquids, lower layers of the liquid would apply a viscous force on this, which would try to retard its motion. Okay, so if I had to find out the value of F would be equal to neta A dv over dy. Okay, so all I need to do is just substitute the values. So A is 2 and V is 2 meter per second, and the depth of the liquid is 1 meter. So you know this is why delta y is 1 meter. Here the v is 2 meter per second. Now please note that the layers, the topmost layer and the bottommost layer of the liquid always stick to the surfaces that they are in contact with. So the topmost layer of the liquid would be moving with v equals 2 meter per second. How about the v here? V dash here would be 0. The bottommost layer would have stuck to the ground. Okay. So neta is 10 to the power minus 3 into area, which is 2, into dv by dy is usually written as delta v over delta y. Okay, so delta v over delta y would again be 2. Okay, so across a length of 1 meter, the velocity is dropping by 2. So delta v by delta y would be 2. Okay, so the answer would be 4 into 10 to the power minus 3 Newton. Okay, that is your answer. Okay, 4 millinewtons. Okay, this is how you solve such a question. Okay, I hope that is clear. In a very simple application. Okay, now let's try another one. With what terminal velocity will an air bubble of 0.8 mm in diameter rise in a liquid of viscosity 0.15 Newton per meter square, Newton second per meter square, and so hi Mahi, how are you? And specific gravity of 0.9. The density of air is 1.2 into 10 to the power 1.293 in SI units. Okay, so hurry up, let's try and solve this. So if you remember the expression for terminal velocity, then it should be fine. Again, if you don't remember it, let me just write it. Terminal velocity was 2 over 9 pi r square rho minus sigma over neta. Okay. So all you need to do is just substitute the different values. Just try and substitute different values, and that is it. Diameter of the bubble has been told to you. The viscosity, coefficient of viscosity in SI units has been told to you. The specific gravity of the liquid has been told to you, and the density of air has been told to you. Okay, so hello Amod, how are you? This is very simple. All you need to do is 2 by 9 into pi into r square. R was 0.8 mm. 0.8 into 10 to the power minus 3 whole square into, now you realize now I have a negative terminal velocity, which would simply mean that the terminal velocity is upwards. Okay, positive terminal velocity is downwards and negative terminal velocity means it is just moving upwards. So here the 900 specific gravity is 0.9, so the density will be 900 minus 1.293 over 0.15. That will be your answer. Okay, that is how you would have found your answer. Okay, so just calculate this value and that's it. You're done with the question. Okay. So the question related to viscosity will be very simple. I mean, the only difficult questions that you see in viscosity are from Poiseuille's equation, but Poiseuille's equation is not in your syllabus anymore. So now the questions that you face in viscosity are super simple. They are either directly related to Newton's law of viscosity or related to Stokes' law and terminal velocity. Again, very simple expressions for all. So with that, let's move on our discussion to surface tension and capillary rise. Okay. So first, we'll introduce the concept of surface tension. So what is surface tension? Surface tension can be defined as a property of liquid at rest by virtue of which the free surface behaves as a stretched membrane under tension and tries to occupy as small area as possible. Okay, so this is an experimental observation. Experimentally, we notice that the free surface of any liquid behaves like a stretched membrane which is under tension. Okay, and it will always try to occupy as small an area as possible. So you know that whenever you have a liquid drop, it always takes a spherical shape. So why do liquid drops take spherical shapes? Because for a given volume, a sphere has the minimum surface area. Okay, so the idea is to minimize the surface area. Now, why does that happen? We will talk about that in a bit. So first, let's talk about this. The idea, mathematically, surface tension is measured as the force experienced per unit length by any surface in contact with the liquid surface. Okay, so again, why are we defining it like this? I will tell you about that also. First, let me just introduce everything. Okay, now the force of surface tension always acts perpendicular to the contact surface. Okay, so these are the things that I want you to know first uh, for about surface tension. Then now we will start about our discussion of why we are defining it the way we are defining and why we are saying about surface tension, the things that we are saying. So let's talk about some experimental observations and the evolution of the idea of surface tension. So why did somebody think about the idea of surface tension? So there was a lot of experimental observations which are unexplained. Okay, so I don't know if you've noticed this. If you take a small pin, you take a small pin of iron, and if you place it on a liquid surface, imagine you have a liquid here, okay, in some container, and on this liquid surface, if you place an iron pin gently, turns out it keeps on floating. Okay, now that is something very strange because iron has a density which is greater than the density of water. So how is it possible that on a surface, if a iron pin is gently placed, then it keeps on floating? Another thing that you would have noticed is that you must have seen mosquitoes can sit on the surface of water. You must have seen this. Imagine you have a mosquito, and this mosquito can sit on the surface of water. Okay, now how is that possible? You realize the legs of the mosquito are very thin, right? So it cannot be the buoyant force that it is hardly displacing any water. The legs hardly have any volume to displace any significant volume of water. So how is it? It cannot be the buoyant force that is balancing the mg. So how is the mosquito able to sit on the surface of water as if it is a solid surface? Okay, how are these things happening? So when looked under a microscope, people realized that if you have a pin placed and if you looked at a liquid under microscope, then what they saw was that this is what the surface becomes. So imagine you had a container in which you had water and you had placed a pin here. It turns out where the pin is placed, the surface deforms. The surface actually bends. The liquid surface actually bends, and it is in fact acting as a stretch membrane. Okay, now why is that happening? Let's talk about that. Why is that happening? So people said experimentally, the only thing that makes sense is that this surface is actually behaving as if there was a stretch membrane on that. If you put something, you realize the membrane would depress, and because of this tension, you would have had forces, and the perpendicular components of these forces would have been able to balance the mg. So again, this is an experimentally seen observation. Now the question obviously comes that how is the surface of the liquid behaving as a membrane, and why is it behaving as a membrane? So the reason is quite simple. It's not that complicated, turns out. So what you realize is that if you talk about various molecules in the liquid, okay, so let's talk about various molecules that are there in the liquid. Okay. So if you talk about a molecule which is suppose situated somewhere in the middle, so you realize it has millions of molecules surrounding it. So this molecule experiences an attraction force in all the directions due to these surrounding molecules. So what you can say is that the net force experienced by this molecule is almost zero. Okay, and this is not even bound to its position. This will randomly keep on moving in different directions. Okay, you will see liquid molecules do not have any fixed positions. They keep on moving from one part to another. Okay. Now, how about a molecule which is located here at the top? Now comes the problem. Talk about a molecule of liquid which is placed at the top. Now you realize this fields experiences forces due to all the molecules downward. Now, how does this force get balanced? It turns out this force is getting balanced by these forces applied by the molecules of the side. So to balance this net downward force experienced by the surrounding molecules below this force has to be very strong. So this is F due to surface molecules, F due to surface molecules, and F due to bulk molecules which are inside the volume. F bulk. to balance the force due to various bulk molecules, the surface molecules have a stronger attraction, turns out. So turns out F between surface molecules is much greater than the force applied by the bulk molecules. That is the only way that this molecule can balance the multiple forces that are being experienced by all the molecules below, and it is still not moving below. Okay, so if you imagine, if even if this is slightly down, if this molecule is slightly down, and even if this angle is negligible, if this force is large enough, then also the vertical components of this force can balance out these bulk molecular forces if this happens. Okay. So what you realize is, for the equilibrium of surface molecules, what essentially is important is that the force between the surface molecules has to be much greater than the force between molecules inside the bulk. And that is why, see, that what is the difference between a solid and a liquid? The difference between a solid and a liquid was the intermolecular forces. In solids, the intermolecular forces are very strong, right? That is why those molecules have fixed positions. In a liquid, the intermolecular forces are not that strong, and that is why liquid molecules do not have any fixed positions, and hence liquids cannot have a fixed shape and size. However, the surface molecules have a force which is much stronger than the force between other liquid molecules, and that is why the surface molecules tend to behave as solids, because their force is not as strong as solids, but still it is harder, it is much higher than the normal force of attraction between liquid molecules. And because of that, the surface somewhat tends to behave as a solid. Okay, I hope you guys followed the logic. Okay, so I can say that since the force between surface molecules is way stronger than that between bulk molecules, bulk molecules meaning molecules which are inside the volume, the surface tends to behave like a solid. So it has properties which are somewhere in the middle between the properties of solids and the properties of a liquid. Now, it is due to this strong force that that these molecules are feeling, due to these surface molecules, that this force is able to support the weight of an iron pin. Okay, it is that strong surface force due to the surrounding molecules that the weight of the iron pin can be sustained. Okay, now imagine if this force is F1 and this force is also F1, Fs and Fs. Let's call it Fs, and this angle was, let's say theta. So what you realize is that for equilibrium of the pin, for equilibrium of pin, Fs 2 times Fs sine theta must be equal to mg. Correct? Now, if you put a pin which is of the double length, then also that weight of that is also supported. Now, you know, m is directly proportional to L. The mass of the pin is directly proportional to the length of the pin, where L is length of the pin. Therefore, what you realize is that surface force due to surface molecules is also directly proportional to length, and therefore you realize force per unit length is constant, and this is what we call surface tension. Okay, that is why surface tension is defined as the force per unit length. Okay, because this force due to surface molecules is directly proportional to the length at which it acts. I mean, that is also very logical, because you realize for any certain length, if you have any certain length, you have number of molecules attached here which are proportional to the length. Okay, so greater the number of molecules which are feeling the surface force, greater would be the net force. That is why you cannot talk about the surface tension force as the net force. In fact, you define it as force per unit length, and that is constant. That is called surface tension, and that is the property of the liquid. The force experienced per unit length is a property of liquid. Now, you also know that tension force, surface tension. Why is it coming? Because all these molecules at the surface, they are experiencing a pull force due to the other molecules. Now you realize the origin of this is very similar to tension force, right? That is why it has been called surface tension. If you remember, if you've seen my lectures on Newton's laws, I told you why does tension force arise. So if I have molecules in a rope, and if I try to pull them away, now, then these guys have a strong intermolecular force, and they do not want the distance between them to change. So they pull all the molecules back so that the molecules do not remain, do not move, or the distance between them does not change. So similar phenomena is happening here due to this strong attractive force. So the surface is trying to maintain itself so as a stretch membrane. Okay, so all the molecules are feeling a pull due to other molecules, and hence you say that the surface is under tension, and that is why this force is called surface tension. Okay. Next, let's talk about surface tension again. And now you will also realize to increase the surface area of any liquid, a work needs to be done. Now, why is that? Again, let's go back to this. So I told you earlier only, a molecule which is perfectly inside the bulk does not feel a net force because of the symmetry, and a net force is being experienced by molecules which are at the surface. Now, if I wanted to increase the surface, hypothetically, imagine if I wanted to increase the free surface. So what I want is I want to bring more molecules here from the bulk here, right? From below, I will drag more molecules and create another surface. So you realize when I'm bringing any molecule to the top, as it approaches the top, as this molecule approaches the top, it will start experiencing a net downward force due to all the bulk molecules. So I'll have to do work against this force. Okay. And that is why to bring a molecule from the bulk within the volume to the surface, you will need to do work. So if you want to add more molecules to the surface, a certain amount of work is needed. Now, where is this work going? Next question is, where is this work going? So this work is going into an additional energy, which is called surface energy. So we say surface molecules, due to their stronger intermolecular interactions, have a certain energy associated with them. Okay, interaction energy. That is what we call surface energy. Okay. Now you will also realize that surface tension can also be defined as the surface energy per unit area. Okay. How do we do that? Let's try and imagine. How do I get this expression? So we can perform an experiment wherein you can consider a thin frame of wire. Okay, so you consider a frame of wire. Okay, and you imagine that this frame of wire has a movable rod, and in the middle you formed a liquid layer. You have formed a liquid layer, trapped a liquid layer here. Okay. Now, what is the force that would be experienced by the rod due to the surface tension here? So you will have two free surfaces here. One at the top, one free surface at the top. What are free surfaces? Free surface is the one which is in contact with water, and one free surface at bottom. Now, the molecules of both the free surfaces will apply a force of surface tension. So if this length was L, if this length was L, so these molecules of the surface will apply a force on this, which is, let's call Ft, which is the force of surface tension. Okay. Now, if I wanted to move this, I will need F external. So imagine if I applied an F external, which is almost equal to Ft, and I made this frame move by a little distance dx. Imagine I shifted this slider by a small distance dx. So if I slowly move, if we slowly slide the rod by dx, work done by F external, work done by F external would be equal to F external times dx. Correct? Now, how much will that be? How much will that be? So that work would be equal to F external. Also, I know F external is equal to surface tension, which is T into L to 2. Why? T into L on the upper free surface, T into L on the lower free surface. Okay. Now, please note that the surface tension phenomena happens only for a few layers of molecules, barely 10 molecules below. The surface extends up to 5 to 10 molecules. That's about it. Roughly around 5 molecules. That's about it. That is called the surface thickness. And below that, we talk about bulk. So the surface thickness is practically negligible. Okay. So here we realize that F external was this. So the work done by, therefore, dW external is equal to 2L into P into dx. Now you realize this caused an additional surface to get created. The additional surface area that got created here, so that is the area in between this. So let's call this dA. So by moving the slider by dx, I have increased the surface area of the liquid by 2Lx, LdX, correct? LdX on the upper side and LdX on the lower side. dA equals 2L Okay, so what I can say is dW external is equal to P into dA. And this dW external, where is this work going? So this work is going into the additional surface energy contained in the additional area. Okay, the additional area that I created, that has to have some surface energy. So this external work is going into that surface energy. So from here, I get P equals du over dA. So that is the proof of this, that surface tension can numerically be also measured as the surface energy per unit area contained in any surface, free surface. Okay. Again, I hope this is clear. Now you have two ways of defining surface tension. Surface tension can be defined as the force per unit length or the surface energy per unit area. Numerically, both are equal and both are equal to this value of surface tension. Okay. Dimensionally also you can see, dimensionally this is work, which is force into distance over area, which is distance square. So this is force over length. Okay. So dimensionally also it makes sense. All right. Next, this magnitude of surface tension depends on the nature of the liquid, the temperature, and the impurities. Okay, first of all, I told you what is the reason for surface tension. It is the intermolecular attraction. Now, how strong is that intermolecular attraction will depend on the nature of the liquid. That is why this is a factor. Then you have temperature. If you increase the temperature, what happens? Okay, if you remember, what happens when you increase the temperature? You increase the average distance between two molecules. So F reduces. Okay, F interaction reduces whenever you increase in temperature. The increase in T will mean reduction in interaction force between the molecules, and therefore T reduces. So surface temperature, surface tension reduces. Okay, if you increase the temperature of any liquid, then its surface tension will always decrease. Next, you have impurities also. As I said, the surface tension force is arising due to intermolecular interaction between the molecules at the surface. Now imagine if there are impurity present. So if there is an impurity atom here, so this impurity will hinder the interaction between these two. Okay, so addition of impurity again reduces the surface tension. Addition of impurities reduces surface tension. Okay. These are the factors on which this force of surface tension depends: nature of the liquid, temperature, and content of impurities. Okay, the greater the amount of impurity is added, the lesser is the force of surface tension. Okay. Next, as one of the applications and the topic on which a lot of questions on surface tension are based is called excess pressure inside a drop. Okay, so just hang on for 1 minute. So here, what I'm trying to do is we are trying to relate the pressure inside a drop with the pressure outside. So if the outside pressure is P naught, I'm trying to find the pressure inside the drop. So for that, what I do is I will break a drop into two halves, and I'm considering one hemisphere. So if I draw the FBD of this one hemisphere of the drop, then I see it is experiencing three forces. One, due to this external pressure. So this external pressure will apply a net force on the outer surface. Then there will be a force experienced by the internal pressure of the liquid. So the second half of the liquid, due to its own pressure of the liquid, would have applied a force. And also the surface molecules of these would have pulled the surface molecules of this. So there are three forces that you can see acting on a drop. There are three forces acting on the drop. Now, which are one, force due to external pressure. Not. Second, force due to internal pressure of the liquid. Third, force on the surface molecules of this hemisphere due to the second hemisphere. Okay, so the surface molecules of the second hemisphere will apply a force on surface molecules of the first hemisphere. So if you look at the direction, so P naught and surface tension force act in one direction and the P acts in the opposite directions. So for the equilibrium of the liquid, for the equilibrium of the hemispherical portion of the drop, I can say summation F would be 0. Okay, and just add a page here. Therefore, what I can say is, so let's see what are the forces experienced by this. Okay, यहाँ पे क्या क्या फोर्स लग रहे थे? एक तो लग रहा था P नॉट का, just the external pressure. Then you would have felt a force due to the internal pressure due to P, and then of course you would have felt the force of surface tension acting on the surface molecule. Okay, and for equilibrium now I can say, for equilibrium the force due to P naught plus force due to surface tension would be equal to force due to P. Now what is the force due to P naught? Now P naught is uniform pressure. So uniform pressure force is always equal to pressure into the projected area. So this term becomes P naught into pi r square, where r is the radius of the drop, plus the force of surface tension. Now surface tension is acting along this length, right? What is this length? This length is 2 pi r. So the surface tension force would be T times 2 pi r, and that would be equal to the force due to the internal pressure, which would be P into pi r square. Okay. So when you figure out this equation, you can cancel out these, and what you realize is P minus P naught equals P over R. That is called the excess pressure inside a drop. This is what we call excess pressure inside a. Okay. Again, I hope this is clear. A very very simple derivation. Excess pressure inside a drop is 2T over R, where R is the radius of the drop and T is the surface tension of the liquid. Okay. Next, you have excess pressure inside an air bubble. So an air bubble is something like this. This is what your air bubble is, right? It has soap bubble. Soap bubble has a thin liquid of a layer of liquid. So let's call this soap bubble. Okay. So you have a thin liquid of layer, thin liquid layer, and then you have this bubble. So here what is happening is that inside air will have some pressure P, and due to that it will apply some force on this bubble, and due to some P, which is the pressure inside the bubble, then you have some pressure outside the bubble, again P naught, atmospheric pressure, or the external pressure, whatever. So that will apply some force. Now you also have surface tension force acting on two surfaces. So here you have two free surfaces. One is this and one is this, the internal surface, free surface, and the external free surface. You have two free surfaces. So for equilibrium of this, for equilibrium of bubble, what you realize is that P naught to pi r square plus 2 times 2 pi r to T is equal to P into pi r square. What you realize is P minus P naught equals 4T over R. This is known as the excess pressure inside a bubble. Okay. Now you might want to note one thing here. Let's make a note of one thing here. When we cross a liquid surface from its convex side, the pressure increases by 2T over R, and when we cross from the concave side, P decreases by 2T over R. Okay, this is a very very important conclusion. Now what is happening here is that if the pressure here is P naught, now if here you talk about P dash pressure, P dash would have been P naught plus 2T over R. The moment you cross one surface, you would have gotten P dash, and P dash would have been 2T over R, and then you cross the surface again. You cross another surface again. Both the times you are crossing surfaces from the convex side. So every time you cross one surface of the liquid, the pressure increases by 2T by R. So that is why you realize P finally is P dash plus 2T by R. And that is why P is coming out to be P naught plus 4T by R. Okay, remember this, very, very important. Okay. So should we look at some questions then? Okay, I hope you guys are following this. I've had a lot of discussion. सारी चीजें डिस्कस करा दी अभी इतनी देर में. Hmm. Okay. Since nobody is asking any doubt, so let's take up a question then. This is a typical question asked from this chapter. Okay. Question tells you how much work is required to increase the diameter of a soap bubble from 2 centimeter to 5 centimeter if the surface tension of soap solution is 3 into 10 to the power minus 2 newton per meter. So try this. Try this. So what is happening when you're increasing the diameter of the bubble? You have to blow to increase the diameter of the bubble. You are blowing a bubble, you have to blow air in it, right? So you have to apply a force, okay, in order to increase. You have to do some work. Where is that work going? That work is going into the surface energy. Okay. So try and find out the answer. What is the amount of work required to increase the diameter of soap bubble from 2 centimeter to 5 centimeter? Think about this and try and give me an answer. Okay, any answers? Any answers then? It's a simple enough question here. थोड़ा सोचो and it'll be very easy. Very, very simple question with a very, very simple answer. Okay. Typical problem of surface tension. हाँ. तो बताओ क्या लग रहा है? Okay, Rishabh says 4.5. 4.5 what? 4.5 क्या? यूनिट्स क्या है भाई? कभी भी आंसर ऐसे देते हो, यूनिट्स तो रखो. 4.5 सेंटीमीटर, 4.5 मीटर, 4.5 जूल, 4.5 न्यूटन. क्या? 4.5 क्या होता है? अभी तक जो डिस्कशन किया है वो सब फॉलो किया आपने ऋषभ? सरफेस टेंशन समझ में आ रहा है क्या होता है, क्यों लगता है? कोई कंफ्यूजन अभी तक का जो डिस्कशन है उसमें? तो राज says 2 millijoules. ओके, ऑलराइट, ऑलराइट. सो बहुत ही सिंपल है. आई टोल्ड यू जो वर्क चाहिए वो किस लिए चाहिए? वर्क चाहिए वो किस लिए चाहिए? सरफेस ज्यादा क्रिएट कर रहे हो, सरफेस एनर्जी एक्स्ट्रा दे रहे हो. तो यू विल नो W इक्वल्स डेल्टा U सरफेस. डेल्टा U सरफेस क्या होगा? T टाइम्स डेल्टा A. तो चेंज इन सरफेस एरिया है, दैट्स इट, तो दैट विल बी द वर्क रिक्वायर्ड। तो वर्क रिक्वायर्ड कितना हो गया, टी इंटू 4 पाई R2 स्क्वायर माइनस R1 स्क्वायर, हाँ, या फिर हम कह सकते हैं टी इंटू पाई D2 स्क्वायर माइनस D1 स्क्वायर। हाँ, सो कितना हो गया, सरफेस टेंशन का फोर्स हमें दिया था 3 × 10⁻², इंटू पाई इंटू D2 स्क्वायर विच इज 5 माइनस D1 स्क्वायर, सो 525 माइनस 4 इंटू 10⁻⁴। ओके, हम्म, ये कितना बना, 3 × पाई इंटू 21 इंटू 10⁻⁶। तो ये हो गया हमारा 66 इंटू 3.14 टू 10⁻⁶। रफली ये कितना हो गया, 200 के आसपास हो गया, 200 इंटू 10⁻⁶। तो मिली में अगर कन्वर्ट करेंगे 0.2 मिली जूल आएगा, 0.2 मिली जूल होगा आंसर। यस, दिस फॉर्मूला। और वर्क डन कहाँ जाता है, वर्क डन कभी भी कैलकुलेट करना है तो टी डेल्टा एस करो, ठीक है, कभी भी वर्क का क्वेश्चन आ गया, वर्क का क्वेश्चन आ गया, टी डेल्टा एस होगा हमेशा। कभी भी फोर्स का आ गया तो टी इंटू एल होगा, वर्क का आ गया तो टी डेल्टा एस होगा, ठीक है। 0.2 मिली जूल होगा, 2 मिली जूल नहीं, 10 की पावर में थोड़ा सा देखना था, ठीक है, बट हाँ ठीक है, रफली रफली ठीक ही आंसर, ठीक है। ओके, सो दिस इज अ टिपिकल प्रॉब्लम ऑफ सरफेस टेंशन। नेक्स्ट एक और प्रॉब्लम ट्राई करते हैं, चलो अब इसका आंसर सब लोग दो। तो आपको बोला है व्हाट शुड बी द प्रेशर इनसाइड अ स्मॉल एयर बबल ऑफ 0.1 mm रेडियस जस्ट बिलो वाटर सरफेस, surface tension is this and the atmospheric pressure is 180 m। हाँ, 180 m रफली कितना होता है, 180 m को 10⁵ पास्कल रख मान लो, रफली 1.1 इंटू 10⁵ पास्कल होता है ना। तो ये बताना है आपको कितना होगा, एयर बबल है जस्ट इनसाइड जस्ट बिलो वाटर सरफेस। अब यहाँ पे थोड़ा सा ट्रिकी है मामला, ध्यान देना ट्रिकी क्यों है। ये सोप बबल नहीं है, सोप बबल से डिफरेंट है एयर बबल। एक एयर बबल और सोप बबल में क्या डिफरेंस है, ये बताओ चलो। व्हाट इज द डिफरेंस बिटवीन एन सोप बबल एंड एन एयर बबल इनसाइड वाटर। एक आपको सोप बबल दिया है, और दूसरा आपको दिया है वाटर एयर बबल इनसाइड वाटर। क्या लगता है क्या अंतर क्या है दोनों बबल्स में। देखो डायग्राम बना दिया मैंने हिंट के लिए। सरफेस, हाँ, इसमें सिर्फ एक फ्री सरफेस होगा, दिस गाय हैज टू फ्री सरफेसेस, एंड दिस गाय हैज वन फ्री सरफेस ओनली। फ्री सरफेस हम किसे बोलते हैं, जो भी लिक्विड का लेयर एयर के साथ कांटेक्ट में है, ठीक है। इधर दो लेयर कांटेक्ट में है, ये वाला यहाँ एयर है क्योंकि, और यहाँ एयर है, तो ये वाला भी फ्री सरफेस है और ये वाला भी फ्री सरफेस है, ठीक है, दोनों एयर से कांटेक्ट में है। यहाँ पर एक ही सरफेस है, एग्जैक्टली एकदम सही। तो एक्सेस प्रेशर कितना होगा, एक्सेस प्रेशर कितना होगा भाई इस केस में, 2T/R होगा, 4T/R होगा, 5T/R होगा, कितना होगा। अच्छा, ये स्फेरिकल बबल्स का है एक्सेस प्रेशर, कोई और शेप हुआ तो अलग आता है, एरोडो वगैरह में सवाल है अलग अलग शेप का, थोड़ा सा सिलिंड्रिकल सरफेस, कर्व सरफेस से भी सवाल है उसमें। 2T/R होगा यहाँ पे एकदम। तो आपको पता ही है फिर तो कुछ भी नहीं रह गया अंदर। P इक्वल्स P0 प्लस 2T/R कर दो। P0 आपका रफली 10⁵ है, प्लस 2 × T आपका हो गया 7.2 इंटू 10⁻⁻² ओवर R जो हो गया आपका 0.1 इंटू 10⁻⁻3। ये हो गया आपका 10⁵ प्लस 1440। ये आंसर हो जाएगा आपका 101,440 पास। ठीक है भाई, ये आंसर हो जाएगा। यस एग्जैक्टली। ऑलराइट, एक और करते हैं फिर, एक और प्रॉब्लम प्रैक्टिस करते हैं जरा। आपको बोल दिया स्मॉल एयर बबल of radius small r is at a depth h below the water surface. If the density of water is d, the surface tension is T, and the atmospheric pressure is P, then find the pressure inside the liquid. Find the pressure inside the liquid. Again, very simple. Now, please note यहाँ पे small air bubble बोला है, ठीक है। स्मॉल एयर बबल बोलने का रीजन है, स्मॉल नहीं होता तो दिक्कत हो जाती हमारे साथ। क्या दिक्कत हो जाती? दो केस लेते हैं, एक में बबल स्मॉल रखते हैं, एक में स्मॉल नहीं रखते। जरा देखते हैं अंतर क्या होता है। सपोज करो आपका बबल जो है एक में बड़ा हो गया और एक में बड़ा छोटा सा है। Okay, sir, are complicated questions asked in kinematics? Yes, sometimes, sometimes, sometimes they are. Yes, Rishabh is absolutely right. P ATM plus rho GH plus 2T/R is the correct answer. एकदम ही सही बात है। देखो यहाँ पे परेशानी क्या होती है, अगर ये बबल ज्यादा बड़ा हो जाता तो परेशानी क्या होती है, यहाँ पे जो प्रेशर होता और यहाँ पे जो प्रेशर होता ये अलग अलग हो जाते, और प्रेशर नीचे ज्यादा होता तो नीचे का प्रेशर ज्यादा कंप्रेस करता, तो ये शेप इनफैक्ट कुछ अजीब सा हो जाता। ये स्फेरिकल शेप ही नहीं रहता, पहली बात स्फेरिकल शेप नहीं रहता, कुछ अलग ही शेप हो जाता, यहाँ से दब जाता बबल। ठीक है, और दूसरी बात फिर आप एक यूनिफॉर्म प्रेशर नहीं बता सकते थे, तो इसके लिए वो एक्सप्रेशन नहीं लगा पाते फिर। ऑन दी अदर हैंड जब तक छोटा है बबल तब तक आपको वो टेंशन लेने की जरूरत नहीं है। जब तक आप बबल बहुत ही छोटा रख रहे हो तब तक स्फेरिकली रहेगा, उसमें इतनी परेशानी नहीं है। प्रेशर ऑलमोस्ट यूनिफॉर्म मान लोगे आप, एक्सटर्नल पी हर जगह सेम मान लोगे। ठीक है, सो पी सेम मान के ऑफ कोर्स फिर वही आंसर होगा आपका। पी वुड बी पी एटीएम which is P dash बोल देते हैं, P प्लस रो जी एच प्लस 2T/R। प्लीज नो 2T/R क्यों, एक ही फ्री सरफेस है इसलिए, एक ही फ्री सरफेस है इसलिए। ठीक है, मेंस वाले स्पेशली यार काइनेमेटिक्स वजह से टॉपिक्स में ना थोड़े से घुमा घुमा के क्वेश्चन पूछ देते हैं, इसमें मैथ्स वगैरह थोड़ी इन्वॉल्व हो रही हो तो ध्यान देना उसमें। या तो काइनेमेटिक्स का पूछेंगे ही नहीं, या पूछेंगे तो थोड़ा सा मैथ्स ज़्यादा लगवा देंगे, ऐसा जनरली करते हैं वो लोग मेंस में स्पेशली। ठीक है, कॉम्प्लिकेटेड फंडे वाइज बहुत ज़्यादा नहीं होगा, बट मैथमेटिकली थोड़ा सा कॉम्प्लेक्स पूछ सकते हैं। ठीक है, ऐसा है चीज। ओके, सो एक और सवाल देखते हैं भाई। Assume that a drop of liquid evaporates by decrease in its surface energy so that its temperature remains the same. What should be the minimum radius of the drop for this to be possible? Okay. So you've been told that the surface tension is T and the density of the liquid is D and the latent heat of the liquid is L. Okay, ये try करो. Hmm. क्या आ रहा है इसका आंसर? क्या आ रहा है भाई इसका आंसर? हेलो चिराग, हाउ आर यू? ओके, तो भाई किसी का आंसर आया? Did anybody find the answer? Okay, waiting. स्ट्रीम हैंग कर रहा है थोड़ा सा. But lag आ रहा है थोड़ा सा. Okay, right. Qt over row L. Okay, capital L that is. I think that's the correct answer. So इसका सीधा सीधा फंडा है. देखो करना क्या है. इमेजिन ये आपका ड्रॉप है, आर रेडियस का. अभी ये थोड़ा सा पार्ट अगर इसका इवेपोरेट हो जाता है, इमेजिन, तो इसका रेडियस डी आर से घट जाता है. ठीक है, तो ये वाला जो पार्ट है ये इवेपोरेट हो रहा है आपका. जा रहे हो, ये पार्ट इवेपोरेट हो गया. ओके, सो जब ये पार्ट इवेपोरेट हो गया डी आर थिकनेस का इसमें से, तो व्हाट इज द सरफेस एनर्जी दैट गॉट रिड्यूस्ड? ओके, तो हम कहेंगे यू क्या था? यू था हमारा 4 पाई आर स्क्वायर टी. सो व्हेन द surface radius decreases by dr, reduction in surface energy is du equals 4 pi into t into 2r dr. Correct? That is the surface energy reduced. Now you want this surface energy to be able to provide the latent heat for vaporization. This should be equal to dm times L, where dm is the mass that got evaporated. Okay. So what you realize is that 4 pi t into 2r dr should be equal to dm. Dm is the mass contained in this small segment. How much will that be? That will be 4 pi r square dr into L into rho. Correct? The volume into density, that is the mass dm into L. This is the latent heat of vaporization. So you can cancel out 4 pi, and r dr and 1 r and dr. And what you realize is that r should be equal to 2t over rho L. That is the required answer. So absolutely correctly answered by Chirag Dubey. Well done. Okay, so this is how you would have solved this. Okay. If that happens, basically you want, essentially what you want is du should be greater than dml, greater than equal to. So that is what will give you the minimum radius. Okay. The reduction in surface energy should be greater than the energy required for vaporization. All right. So that is bringing us to the end of our lecture for today. And somebody has asked a question. तो मेरा एक फ्रेंड है, उसकी प्रिपरेशन 1% भी नहीं है, और वो आज से पढ़ना चाहता है मन से। उसके पास लेक्चर्स हैं, देन लेक्चर्स प्लस नोट्स और पीवाईक्यूज कर ले, काफ़ी रहेगा। हाँ, इतना भी कर लेगा तो ठीक ठाक है यार, ठीक ठाक है। क्या है, अगेन अगेन यार, अब देखो, अब अभी से भी अगर आप करना शुरू कर दोगे तो दैट इज गोइंग टू बी बेटर देन खाली बैठने से तो अच्छा ही है ना। और प्रिपरेशन कभी वेस्ट नहीं जाती। सो इवन इफ अगर आप इस बार भी अभी पूरी मेहनत करते हो और मान लो डिजायर्ड रिजल्ट नहीं आता है और आप फाइनली 1 साल का ड्रॉप लेना चाह रहे हो, मान लो, ठीक है, हाँ, टुमारोज टॉपिक इज प्रेजेंट, तो भी ये आप जो अभी मेहनत करोगे ये अगले साल तो काम आएगी आएगी। वर्स्ट केस सिनेरियो भी, मेहनत कभी वेस्ट नहीं जाती। ठीक है मेरे दोस्त, ये याद रख लेना। और जब जागो तभी सवेरा, कोई ऐसी दिक्कत वाली बात नहीं है। ठीक है, आप कभी भी तैयारी शुरू कर दो। ठीक है, पहली बात तो इतना लेट करना ही नहीं चाहिए था, बट ठीक है, अब आप अभी भी कर दिया है तो अभी भी अपना बेस्ट दो। एंड यू नेवर नो, यू नेवर नो। ठीक है, कभी कभी थोड़ी किस्मत साथ दे जाती है तो काम बन भी जाता है। मे अटेम्प्ट के लिए तो फिर बहुत टाइम है अभी। अभी तो बहुत टाइम है, 3 महीने तो बहुत है। 3 महीने में तो आप काफी कुछ बदल सकते हो रिजल्ट में। ठीक है, तो उसकी तो टेंशन ही मत लो, उसमें तो लगी जाओ। फेब पूरा, मार्च पूरा, अप्रैल पूरा है, बहुत होता है 3 महीना। ठीक है, मे अटेम्प्ट के लिए तो आई थिंक बल्कि काफी सिग्निफिकेंट इंप्रूवमेंट कर सकते हो। ठीक है, तो इसकी टेंशन मत लो। ठीक है, तो एक चीज और डिस्कस करना था मुझे, मैं भूल गया, आई थिंक ऐड करना है ना, जब दो बबल कोलीज करते हैं। कोलीज की स्पेलिंग देख लेना। आई थिंक यही होती है, कोलिजिंग ऑफ टू बबल्स। एक ये छोटा सा टॉपिक और रह गया था जो मैं डिस्कस करना चाहता था। ठीक है, तो एक ये और डिस्कस कर लेते हैं, फिर विल एंड टुडेस टॉपिक। तो इमेजिन इमेजिन यू हैव टू बबल्स ऑफ रेडियाई R1 एंड R2, है ना। आपके पास एक ये बबल है R1 रेडियस का और एक ये बबल है R2 रेडियस का। अभी ये जब पुलिस करते हैं, पुलिस करते क्या है, मतलब जब चिपक जाते हैं, जब चिपक जाते हैं तो क्या होगा, क्या होगा कि अलग अलग कलर से बना देते हैं। इन्हें आप चिपकाओगे तो कुछ ऐसा होगा, ये R1 रेडियस रहेगा और यहाँ पर कुछ अजीब सा चीज हो जाएगा, ये R2 रेडियस रहेगा, और जहां पे ये चिपका चिपक रहे हैं वहां पे ना कुछ अलग ही बन जाएगा सर। ठीक है, तो इधर तो ठीक है R1 रेडियस, इधर R2 रेडियस, और इधर का ना सरफेस का रेडियस कुछ बदल जाएगा, R हो जाएगा। तो द आइडिया इज टू फाइंड द रेडियस ऑफ द कॉमन पोर्शन, फाइंड द रेडियस ऑफ कर्वेचर ऑफ द कॉमन पोर्शन। एक स्टैंडर्ड सा चीज है जिसपे सवाल आते हैं, ठीक है? तो वो कैसे निकालेंगे, उसका बहुत ही सिंपल सिंपल फंडा है। आपको पता है आपका यहाँ पे प्रेशर पी नॉट है, ठीक है? यहाँ पे प्रेशर पी नॉट है, यहाँ पे प्रेशर पी नॉट है, तो जब पी नॉट से इधर क्रॉस करोगे, इधर क्रॉस करोगे, तो इधर एक अंदर प्रेशर आया P1 और इधर एक प्रेशर आया P2, ठीक है भाई? तो P1 और P2 हम निकाल सकते हैं। So what is going to be the value of P1 and P2? So P1 would be equal to P naught plus, since this is a bubble, so 4T over R1, and similarly P2 would be equal to P naught plus 4T over R2. Now assuming R1 is greater than R2 is greater than R1, R2 greater than R1, तो ये चीज ज्यादा होगी, P1 ज्यादा होगा। P1 ज्यादा होने की वजह से अगर आप कॉमन सरफेस को देखोगे, कॉमन सरफेस इधर की तरफ बल्ज करेगा, ठीक है? एंड इट विल हैव सम रेडियस R, और वो मैं कैसे निकाल सकता हूँ? अगर मैं यहां से यहां क्रॉस करूं, यहां से यहां क्रॉस करूं, तो कॉन्वेक्स साइड से क्रॉस कर रहा हूं, तो क्या होगा? प्रेशर रिड्यूस होना चाहिए। तो आई कैन से प्रेशर रिड्यूस होना चाहिए। सो P2 would be equal to P1 minus 4T over small r। तो अगेन यहाँ इन सब की वैल्यूज डाल दो, तो आया P नॉट प्लस 4T over R2 equals नॉट प्लस 4T over R1 माइनस 4T over R, ठीक है? तो ये पी नॉट कैंसिल हो जाएंगे, सारे 4T's कैंसिल हो जाएंगे, एंड व्हाट यू विल रियलाइज इज दैट 1 over R equals 1 over R1 minus 1 over R2। सो ये एक बहुत ही स्टैंडर्ड सा प्रॉब्लम होता है, एंड वेयर R would be equal to R1 R2 over R1 plus R1 minus R2, R2 minus R। So very standard problem where basically you're making two bubbles stick together and you're trying to find out the radius of the common portion. Okay, so Lokesh says, sir, in your gravitation lecture 2, sir, you told that Cavendish had given the value of 5.9 into 10 to the power minus 11, but later who corrected the value to this? So it was corrected over a period of time. As we got better and better instruments, we corrected the values. I mean, there is no special credit to anybody, because it was not any personal contribution that corrected the value. It was just the better precision of instruments, right? So the credit is to instruments, not to a person. Credit is to better instruments and better measuring ability. That is why we do not. There is no specific contribution to or name given to anybody. Okay, I remember some 5 years back, I was flying from Delhi to Lucknow, I think. So there I met a guy in my flight who was studying in IIT Kanpur that time. And he said that in his lab experiment, they had done a lab experiment in which they calculated the value of G using some laser thing, which helped them measure it very precisely, and they got the value of G correct up to 11 decimal places. Okay, 11 digits they got right with the help of better resolution and better measuring ability. So I mean, there is no credit given to some single person for that. Okay, because it was just a matter of getting better instruments, getting your hands on better instruments. I mean, it's not like somebody came with a more indigenous method of measuring the value of G. Okay, so that is why we still give credit to Cavendish only. Okay, all right. Same thing you will realize for the speed of light also. A lot of people try to calculate the speed of light. Michelson's experiment, I think it's one of the more popular, though it did not give a very accurate value, but still that was one of the best methods then. All right. So I think that's why you will hear Michelson's name and his apparatus. All right. Anyhow. So this is where I would like to wrap up today's discussion, and then in the next class we will discuss the rest of the topics that I wanted to discuss on surface tension. Okay, so we will discuss about capillary action and everything else that is left in surface tension. We will try to wrap it up in our Wednesday lecture. And tomorrow, yes, we will be talking about prisms. Tomorrow, prisms. I think we were already talking about prisms. We will be talking about thin prisms tomorrow. Tomorrow we will talk about thin prisms. Okay. All right. In any case, before I wrap up today's lecture and before I let you guys go, let me just quickly remind you, if you guys haven't gotten your Plus subscription, if you're planning to get them, then these are the steps that you need to follow. You can go to the Plus section of your app, select your goal as IIT and click on that Get Subscription button. The moment you do that, you will be redirected towards the payment page where you will find a box that will say, do you have a code? So yes, now you do. And that in that box, you can enter this code, RD Live. This code will give you a 10% off on all your subscription fees, whether you choose the Plus subscription or the Iconic subscription. The fees of both these subscriptions are mentioned here, and you realize once you click on proceed to pay, you will also get a lot of no cost EMI options to choose from, which will help you reduce the burden of these payments. Now, the pricing of these subscriptions also you will realize has been kept very competitive. So if you notice here, the 6 month subscription costs you around 4,200 a month. The 12-month subscription costs around 2,800 a month, and 24-month subscription costs around 2,100 a month. So at these prices per month, you are getting highest quality education for all three subjects. Trust me, I know people paying more than this for one subject for their home tuitions in class 6th and 7th. Okay. So I think Unacademy is trying to bring you affordable quality education. So at these prices, I think this subscription is a must-have, and you can again choose a lot of no-cost EMI options also, and of course apply this code to get an additional 10% off on all these fees. All right, for those of you who do not know what the Iconic subscription is, again, so the Iconic subscription takes your IIT JEE preparation to the next level by allotting you personal coaches. So from our team of experts, you will be allotted some personal coaches who will mentor you throughout your IIT JEE journey and monitor your performance throughout, keeping close tabs on your performance. Along with that, you will also be able to attend a lot of IIT JEE workshops, receive expert guidelines from time to time, receive study planners, and receive regular test analysis sessions. So with all these extra benefits apart from your plus, you will definitely power through your IIT journey. And this subscription is more relevant for students who think that they perform better under more individual attention. So these personal coaches will help you get more individual attention. So if you prefer that, then you should definitely go for the Iconic subscription. All right. Next, students who have just entered class 11th and are wondering how to go about their studies for the next 2 years, so need not worry too much. So Unacademy is now bringing you combo subscriptions. So these combo subscriptions take care of your class 11 CBSE studies, your class 12 CBSE studies, your board studies, your IIT JEE Mains studies, your IIT JEE Advanced studies. So everything that might be bothering you about the next 2 years. Again, you can choose a combo and then forget about all your worries. So the first combo that Unacademy offers gives you the Iconic subscription for IIT JEE and Plus subscription for 11th and 12th. And this subscription costs at around combo costs at around 4,600 a month. Then second combo that you can choose from provides you the Iconic subscription for all three. And this combo costs you around 5,500 a month. Then the third combo offers you the Plus subscription for IIT JEE and Plus subscription for 11th and 12th. This combo comes to about 3,000 per month. And finally, you have a combo where you get Plus subscription for IIT JEE and Iconic for your 11th and 12th. This combo comes at around 3,900 a month. Again, you can choose a combo which suits your personal needs. Okay, you know better where you want to focus more, where you think you need better support. So choose a combo and then leave the rest of your worries behind. Right. Those students who are following us on the JEE English channel of YouTube, do not forget to connect with us on the Telegram app using this link. So often what happens is that what is the rate of change of speed? The rate of change of speed. Okay. So we don't define a term for that, Lakshmi. We only talk about rate of change of velocity. We do not define a term for rate of change of speed. Okay. There is no term defined. Okay. So if you watch my kinematics lectures, I don't know if you have. There I had asked this question, in fact. Why don't you define a rate of change of speed? Why don't you do that? I don't know if you're coming from there only. So as I said, a lot of students give me feedback that they have, subscribed to the channel, they have clicked on the bell icon, they still do not receive timely notifications. So yes, YouTube does that. To avoid that and not to miss out on any of the amazing lectures and sessions happening here, you can connect with us on the Telegram app. This will make sure that you're receiving all timely notifications of every lecture and session happening here, and you're not missing out on anything. Okay. Next, this is where I wrap up. And before I leave you, let me finally remind you one last time that this is one code which will help you in many ways. So you can obviously unlock free features of the Unacademy app using this code. Then you can get 10% off on all subscriptions. And you can enroll in various Unacademy events also. Like the Unacademy Combat and other events. Yeah. Turns out we do not define a rate of change of speed, and the reason for that is it has no practical utility. There's no practical utility. So that's why we do not define something called as rate of change of speed. We only define a rate of change of velocity, which is the acceleration. Okay, it's the counter. Uh, let's say the counterpart, the scalar counterpart of acceleration is not defined. We in fact do define rate of change of acceleration also. Rate of change of acceleration is called jerk. If you wanted to know, you have something called jerk, which is dA by dt. Rate of change of acceleration. Because this is a vector quantity. Okay, which is d3s by dt2. d3. Okay. So we even define that, but we do not define rate of change of speed. Okay. All right. So with that, let's wrap up today's session. And now I'll see you next with the next session on fluids day after tomorrow. Till then, you guys keep studying hard and keep practicing. Okay. And take good care of yourself. Bye bye. Take care.